I have been assigned the task of constructing a wall. There is a certain amount of work that I can do every day, and hence for the entire wall I am going to take a certain number of days. However, after working for one day, I realized that I need to rest for the next day. So essentially what I am doing is I am only working on alternate days. So I work on the first day and I build some portion of the wall, and the rate at which I do my work is a constant rate every day. So on the first day I construct some part of the wall, take a rest on the second day, again go back to construction on the third day, take rest on the fourth day, and so on. So I am only working alternate days. However, I realize that the day I am not working and the day hence on which I am resting, some people actually come and break up some portion of the wall that I have constructed. And they also work on alternate days, on those days that I am resting, and the rate at which they break the wall also is constant. So let's go through this again. I am constructing some portion of the wall on alternate days at a constant rate. There are some people who are breaking down the wall on the other alternate days, which is also at a constant rate, and the breaking will go on only till the entire wall is constructed. Once the entire wall is constructed, they will not get into any breaking. If I had worked on consecutive days without any breaks, I would have completed the construction of the wall in 15 days. So that's the rate of work that I do. Also, if these people who are breaking the wall had gone on breaking on every day, consecutive days, and if they had started with a full wall constructed, then it would have taken them 20 days to break down the entire wall. So if this is the data given to us, and if we are still talking about a situation where I am going to work on alternate days and those people are going to break down on alternate days, then in how many days will I eventually completely build the wall? To answer this question, we need to understand concepts of work, and let's go through these concepts and then answer this question. What is this whole concept of work being done? So let's look at how we can express work. Work can be written as the number of people multiplied by the rate of work per person per unit time multiplied by the time. So what we are saying is that if there are 5 people who are working and they are working at a certain rate per person and per unit time, which means on a per day basis, and suppose they are working for a certain number of days, then when we multiply this number of people who are there by the rate, by the number of days, we would actually get the total work which has been done by all these people put together. So now if I say, suppose there is only one person, and if we say that one person can complete a piece of work in 10 days, if one person completes some work in 10 days, then how much is the work done per day? It would be 1 by 10. So work done per day is 1 by 10, and on the other hand, if you are told that work done by a person, let's say on a daily basis, is 3 by 5, then in how many days will the work be completed? It would be 5 by 3 days. So we are just playing around with reciprocals out here. Now if we look at this particular statement, this would tell us that the rate of doing work, and if I look at the time, then they would be inversely related, which would mean that if the rate of doing work per unit time increases, then the time required to do the job decreases. I am assuming that the total work is constant and the number of people is constant. So if these two parameters are constant, then these two parameters are inversely related. Similarly, if work to be done is constant and the time available is constant, number of people and the rate would be again inversely related, which would mean that if the rate per person per unit time increases, then the time is constant, work is constant, then the number of people required to do the job would decrease, and hence the number of people is inversely related to the rate. So looking at this one statement, since there are 4 parameters, if any 2 are constant, we can find out the relationship between the other 2. So based on all this, if we say that the rate of work changes in the ratio A is to B, that means if this parameter changes in the ratio A is to B, and if these 2 parameters are constant, then the time required to complete the work would change in the ratio B is to A. An outcome of this, that they are inversely related. Now suppose we try and relate the work to be done and let's say the rate per person. So if the number of people is the same and the time remains the same, and if the rate per person changes in the ratio A is to B, then the work done will also change in the ratio A is to B, because if these 2 parameters are constant, then these 2 have a direct variation amongst them. So if this changes as A is to B, this would also change as A is to B. So bottom line is that if this one statement is clear to us, out of these 4 parameters, any 2 remaining constant, we can figure out what is the relationship between the other 2 and accordingly take the relationship, which is whether something is going to increase or decrease depending on inverse or direct variation. There can be many different possibilities in terms of variations for questions asked on work done. So let's look at a few of these variations. Suppose we have 3 people working simultaneously on a job. You have a person X, a person Y and a person Z, and you have been told their individual times that they will take to complete the piece of work. So suppose we have been told that X takes 10 days to complete a piece of work alone, Y takes 15 days to complete a piece of work alone, and Z takes 25 days to complete a piece of work alone. Now the question is, if they work together simultaneously on this job, then in how many days will the work be completed? Now the way we would look at it is, we would convert everything in terms of 1 day's work. So when I look at X, if X takes 10 days to complete the job, then X is 1 day's work is 1 by 10. For Y it would be 1 by 15, and for Z it would be 1 by 25. If these 3 people are going to work simultaneously, then total 1 day's work would be 1 by 10 plus 1 by 15 plus 1 by 25. If we find the LCM for this, it would be 150, and hence we would get 15 plus 10 plus 6, which would make it 31 by 150, and this would be the total work done on any one day by X, Y and Z together. Now if this is 1 day's work for all 3 people put together, then reciprocal of this, which would mean 150 by 31, would be the number of days required to complete this job when all 3 people work on it simultaneously. This method is what we call as the reciprocals method, because we convert the time taken by considering the reciprocal into work done per day, finding the total work done per day, and again finding the reciprocal of that to find the number of days required. There is another method that we can use, which we call as the units of work method. Now what do we mean by units of work method? We start off by taking the LCM of 10, 15 and 25, which we know is 150, and we assume 150 units of work to be done. Now we know that X completes 150 units of work in 10 days, which would mean that X does 15 units of work per day. If Y completes 150 units of work in 15 days, then we know that Y does 10 units of work per day. And similarly, Z would complete 6 units of work per day. Since they are working together, we would know that total work done per day would be 15 plus 10 plus 6, which is 31 units per day. And if 31 units can be completed in one day, then 150 units can be completed in 150 divided by 31 days. Obviously the answer has to be the same, but when you try and solve a question in this manner as compared to the reciprocals method, it just seems a little better because you can perform a lot of calculations orally, whereas here you need to write down all this in terms of reciprocals, and when you are dealing with reciprocals and the calculations following the reciprocals, there is a possibility of an error creeping in, and hence personally we recommend the units method is better as compared to the reciprocals method to solve any question involving work to be done. We've just looked at an example where multiple people were working and all of them were simultaneously working, which means they were working together. Let's now look at a case where these people don't work together but they work alternately. So let's take an example. Suppose we say we have a person X who can complete a piece of work, let's say in 15 days, and there is another person Y who can complete a piece of work alone in 25 days. So if X works alone, X will complete the work in 15 days. If Y works alone, Y will complete the piece of work in 25 days. Now the problem says that they work on alternate days, and on any one given day, hence only one of these two people will work. And if the question is, if they work on alternate days, in how many days will the work be completed? Now the answer to this question depends on whether X starts work or Y starts work. So let's look at both the possibilities. If X starts on the first day, we will go back to our units method and we will say that 75 units is the total work to be done, which means X will do 5 units per day and Y will do 3 units per day. Now if X is going to do 5 units per day and Y is going to do 3 units per day, and if X is going to start, then we know in 2 days 8 units of work would be done. And hence if we keep taking multiples of 2 days, we will reach 18 days, and by then 72 units would be done. We have intentionally taken a multiple of 2, which is not going to exactly give us 75, it's one prior multiple. So in 18 days, 72 units of work have been completed, and at the end of this, on the 18th day, Y was working, because on every odd day X works and on every even day Y works. 3 units of work are pending, and on the 19th day now X is going to work, and we know that X does 5 units of work on any one given day. So since only 3 units are pending, on the 19th day 3 units will be completed in 3 by 5 days, so we don't even need the entire 19th day, we need only 0.6 more beyond the 18 days, and hence our answer is in 18.6 days the entire job would be completed. This is the case when we know X starts. Let's see what happens when Y starts. We still have 75 units to be done. We still know X will do 5 units per day. We still know Y will do 3 units per day. And hence, when we talk about in 2 days, we would still have 8 units of work being done. and in 18 days we would still have 72 units of work being done. Now what's going to happen is 3 units are pending, and we know that Y is going to work now after 18 days, and on any one given day Y does 3 units of work. So for the remaining 3 units Y will take 1 full day, and hence in this case the entire work will be completed in 19 days. So this is how your answer can be different when 2 people are going to work on alternate days, depending on who starts the work and what is the rate of that particular person's work, which will result in this difference of number of days required.